the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Gear and safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
It gives me goosebumps every time I see it. Just amazing. I hope everybody kept their hands and arms inside the vehicle at all times while it was in motion. So I do need to say, I wouldn't be sitting at this podium and you wouldn't have all seen that amazing imagery without a lot of support from an amazing team, both those who worked directly on the EDL cam task as well as those who supported us across the project. I thank you for everything you've done to get us here today. Just an amazing, amazing accomplishment. So I'm going to turn over to Al. Al is going to be our color analyst. Doesn't have a telestrator, but he's going to actually walk through some of those videos in even more detail and actually show you some just incredible things that you can actually see once you look at those videos over and over.
I'm not sure the color commentator is supposed to have as many chills as I do right now and every time I see these videos. But I wanted to add my thanks to the EDL camera team. I mean, these videos and these images are the stuff of our dreams. It's been what we've been dreaming about for years. So thank you so much. Let's see. As Dave mentioned, we'll try to walk through what we see a little bit. We won't take that much time because we could spend literally all day looking at these videos, and some of us have spent all the weekend looking at these videos. But we'll just try to show you some highlights of what we've been seeing and invite you all to continue to look for more things as we kind of see new things every time we look at these videos. So let's start with the parachute uplook camera, and let me give you a quick warning to not blink because things go really fast here. You can see that you can get a sense really of how violent that parachute deploy and inflation are. The parachute pack, the parachute is packed so densely that the pack is basically the same density as oak, and it's about 150 pounds. It gets launched out of the spacecraft with a mortar, which is basically a cannon, with a muzzle velocity of around 100 miles an hour. And the spacecraft itself was going about 1,000 miles an hour at this point, going about 1.75 times the speed of sound. So just in case you blinked, let's show you that one more time. You can kind of see that in high speed, and then or real time, and then we'll slow it down and take a look at the details. Okay, so let's try to walk through this a bit slower, this time at about quarter speed, and we'll pause at times to point out things we see. So let's start that rolling. Okay, here you can see the pack getting pushed out of there. You can kind of see the pack right in the middle as it's being pushed, and the parachute lid, which is right on top of it, it's kind of that circle to the left of the pack, was on top of the pack. It was there to protect the parachute during entry. It's got some thermal protection system material on it to keep the parachute nice and cool and protected. And the pack is used to push that lid right off the vehicle, given that cannon force. You can also see some of the other things that have popped off of that lid, which is kind of expected given how violent this launch really is. So let's move on from here. So we keep going out here. You can see the pack reach what we call line stretch. So that's as far as it's going to go. It's where the parachute's going to start inflating. That's about 150 feet behind the spacecraft, and it got there in just under 1 second. So this pack is really moving. That's pretty much, as the parachute starts to come out, you can see the pack is rotated about 90 degrees. That's pretty common. We've seen that in some of our testing here on Earth at high altitude as well. So let's keep going and take a look at the inflation. So that inflation really looks textbook. It's nice and symmetric. The parachute opens in only about 7/10 of a second, again, really fast. There's no evidence of tangling of the lines, which is great. There's about 2 miles of lines in the parachute system, so the fact that we don't see any evidence of tangling or any kind of other misbehavior is great news. And I'm sure we'll be studying this video for many, many years and picking it apart frame by frame. And of course, we have a second camera on board as well that recorded this launch and inflation of the parachute. You might notice the pattern that's on the parachute here. Distinct patterns are useful in helping us determine the clocking or orientation of the parachute. Also, the contrasting sections can be useful in tracking different positions of the parachute, different portions of the parachute as it inflates. So it's especially useful when we have multiple cameras, as we do here, and are trying to track features in the parachute inflating. In addition to enabling incredible science, we hope our efforts and our engineering can inspire others. Sometimes we leave messages in our work for others to find for that purpose. So we invite you all to give it a shot and show your work. Let's move on to the Rover downloop camera and take a look at that in a little bit more detail. So if we start that up, you can see the heat shield falling away very nicely and symmetrically. Pausing here, we can take a look at what we see on the heat shield. First, we see the medley components on the heat shield. You can see the electronics box and the gold wires that lead to all the various sensors that measure the aerodynamics and heating during the entry portion of flight. We can also see some white flecks in different places, both on the heat shield and free flying, which are likely frost that accumulated on the heat shield. That heat shield is really, really cold during cruise, so it's not at all unexpected to see some of that frost appearing on the heat shield on the inside. You can also see something we didn't expect to see if you kind of look at the 4 o'clock position on the heat shield or so, towards the middle, somewhere between the middle and the edge. One of the springs that helped push the heat shield off seems to have come loose. It doesn't, it's not much of a big deal, but it's definitely not what we expected. If you look at the other 8 springs, they actually are where they're supposed to be, all around the edge of the heat shield. There's no danger to the spacecraft here, but it's something we didn't expect and something we wouldn't have seen if we didn't have the camera system to show us what was going on. So let's keep rolling here. We can see that the heat shield basically stays in the same orientation as it flies away from us. It'll come back into view in a little bit. But this is great. This is kind of what we expected in terms of the aerodynamics of that heat shield. It doesn't tumble or do something weird that was unexpected in flight. So that's very useful to have this video to show us that. So in the interest of time, let's skip ahead to about 15 seconds before backshell separation. So starting this video here, you can see that the spacecraft is rocking back and forth while hanging under the parachute. This rocking is less than it was earlier in flight, but pretty much what we expect. There, that white flash was backshell separation, and you can see us throttle up and begin our divert maneuver. You can see the vehicle's turned over, so we're actually beginning to fly east. And that's why you can see the delta over there. As it maneuvers eastward to the eventual landing site, it actually passes over the field of view, will pass over the landing site and then kind of overshoot it a little bit because it's got to stop that horizontal divert that we did. You can see everything's nice and smooth now that the engines are under control, that on-chute parachute rocking is gone. So here we are, slowing down and stopping, and we're coming straight down on our eventual landing site here. You can see that as we really begin to slow down here, you can see the engines as we get lower throttle up there and stop us here. And you can see it beginning to push all that dust around on the ground on the two sides. That shaking there is the rover deploying and the mobility during sky crane. And here we are coming down, and that rocking motion of the rover we'll see in other videos. But that settles down right before we hit the ground in a nice, safe, flat spot. There doesn't appear to be too much of concern that's right below us. So that was the rover's view looking down. Let's take a look at the descent stage view looking down as well during that sky crane portion of flight. So here we go. The rover begins to drop away from the descent stage, and that's the first part of mobility deployed. You can kind of see here right before we pause that the mobility kind of shook a little bit in that first deployment. Here you can see the bridles that are hanging down from the top of the picture. Those are what's supporting the weight of the rover below the descent stage. And if you look down toward the left, the bottom part of the image and toward the left, you can see that gold umbilical. That's what's transferring all the information between the rover and the descent stage, including this video. This picture is coming down from the camera up on the descent stage down to the rover through that cord, in addition to other information that's going back and forth. So as we keep going here, you can see the bogie deploy. That's on both sides of the mobility back. You see those wheels, the back two wheels on either side swing down. That caused a little bit of rocking of the rover as expected, but you can kind of see that kind of settles out a little bit right as we enter that plume and dust cloud as we get down and touch down. And the video ends at touchdown, of course, because the camera that's taking this video is about to leave this area in a hurry on that descent stage after we cut it loose from the rover. So now let's take a look at the rover uplook camera. So now staring up at the descent stage from the rover. So here we go. We got a really close-up look at the descent stage, and we can start rolling that. You can see the descent stage as the rover begins to fall away from it, and see the effect of that rover wobble from the mobility deploy. So pausing here, the first thing that most people will probably notice is that there's no plumes or no visible smoke or anything else coming out of the rockets at the corner of the descent stage. And that's expected. Hydrazine isn't a combustion reaction when we burn it. The exhaust products are nitrogen and hydrogen, which are clear. So we expect the plumes to be clear. That's what we see in tests here on Earth as well. So I can promise you those engines are on, though. One thing you can see in the Earth testing we do is that the thrust chambers of those engines get kind of hot and glow pink. And you can kind of see that in the engines here, especially if you look at the engine at the very top right of this image. If you look closely right above the engine bell there on the thrust chamber, you can see little streaks of pink on there. And that's what's happening. As the engines have been on for a long time, they get really hot. And that heat shows up there in those pink stripes that we see. So take a look at that closely when you get a chance to look at the image in some detail. As with the previous videos, you can see the bridles that are supporting the weight of the rover there at the bottom now of this image, and that umbilical, again, transferring data back and forth between the descent stage and the rover. So let's keep going a little bit more. You'll see the image begin to wobble a little bit here. I can promise you it's not the descent stage wobbling, it's actually that rover tipping back and forth a little bit as we saw as the mobility deploys, both the first initial mobility deploy and then the bogies deploying. As we near touchdown, let's slow it down a bit and proceed in slow-mo here. So now we're watching about quarter speed. Things are getting pretty dusty here as we get down toward the bottom. Take a look here at the bottom left of this picture. You'll see actually the instant that we cut the descent stage away. And you'll see those bridles begin to get retracted up toward that descent stage as they're pulled up. And this is as planned. There they go. See as they got yanked up there right before. And then we'll see the descent stage begin to turn and ascend and head out toward the northwest with the umbilical dangling behind it. Since the rover was pointed almost directly to southeast, the descent stage chose to go toward the back. That's also to make sure, of course, that the engines don't plume the rover, that we don't damage the rover with that